Nice, straightforward, improper integral.
Alright, that's long enough. So what do we do? So you look at this and you see that there's an infinity in the limit of the integral. Okay? In the top one or the bottom one, it doesn't matter. So you have to rewrite the integral without the infinity. So you pick a letter, substitute for infinity. Let's see, what's a good letter to use today? 30 letters. V? I don't really want to use V. My V's are bad, but V, as in W for Wolfie. So limit B goes to infinity. Integral from phi to B of dx over x cubed. That would be, okay? And this could be a very straightforward integral. So first let's just integrate dx over x cubed. So that's x to the minus 3 dx. And that's, the integral of that is x to the minus 2 over minus 2, also known as negative 1 over 2x squared. You guys all got there? Okay, so this is now going to be the limit as b goes to infinity of negative 1 over 2x squared evaluated from 5 to b. And you plug in the b, and you plug in the 5, and then you take the limit. So this is negative 1 over 2b squared plus 1 over 50. And if you do the limit, b goes to infinity, negative 1 over 2b squared plus 1 over 50. That's 0, so this is 1 over 50. Okay? Straightforward? Nice and simple, okay? Remember I told you, if you have dx over x to the p is greater than 1, it's going to converge, and if it's less than or equal to 1, it's going to diverge. Okay? Alright, now, there's other types of improper integrals. These are integrals where you have a problem, essentially of a discontinuity. Here, let's see this. You good on this one? Suppose you had integral from 2 to 5 dx over the square root of x minus 2. That's the one they use. Yep. Now you look and you say, well, now you have to pay attention when you're doing these integrals, okay, especially the definite ones. This doesn't exist at x equals 2. So x equals 2, you have 0 in the denominator. So you can't really do this integral with a 2 in there. So what do? Well, that's what we're going to have to figure out if the antiderivative works. Right? We have to integrate it. But you can't really evaluate it from 2 to 5, because at 2, it doesn't exist. So we do our trick again to make up a letter. Use B for Bonnie. Okay, and we do the limit as b approaches 2. Now, where are you approaching 2 from? You're approaching 2 from the positive side of the integral from b to 5 of x minus 2 to minus a half dx. Right? Because 1 over the square root is to the minus a half. Why do I put the plus in there? Well, because I'm going between 2 and 5. The other one, you're going up to infinity, so you don't do a plus symbol or a minus symbol, right? But between 2 and 5 means I'm starting at 2, right? Think of the number line. Starting at 2 and I'm going to 5, so I want the limit from the right side. Okay? I don't really think the plus is that important, but you should know that it should be there. Okay? So now, same trick. We have to integrate that. So integral of x minus 2 to minus a half dx is x minus 2 to the positive a half over a half, also known as 2 radical x minus 2. So this is going to be limit b goes to 2 plus of 2 radical x minus 2 from 2 to 5. So plug in the 5, plug in the 2, and see what happens. When you plug in the 5, you get 2 radical 3 minus 2 radical 0. And then, I shouldn't need 2, I'm sorry. Jump to step. Plug in b. minus 2 radical e minus 2. And now, when you take the limit that this is 0, so this just equals 2 radical 3. Does that make sense? So these really aren't crazy tricky. You just remember, you have to do the limit, and you have to do the integral first using a letter, and then taking the limit. Well, when you have these rational functions, remember they're not defined where the denominator is 0. So you have to look, whenever you have a function that you're integrating and you have a denominator, make sure, if you're doing limits of integration, to make sure you remember that it's not defined where that's 0. Okay, we sort of ignored that for a while. Now we're figuring out what to actually do with it. That's another fun one. Okay. Ready for another one? Sure. I'll let you guys do it. How about that?
Because like when it converted it to 0, and then it really stopped 0.
The problem is 2. So what you want to do is give you a clue. You're going to want to make this okay? That's why it's improper. What you can't do is just say, that's ln of x minus 2 from 0 to 3. You can't just do that. Okay? Because you have a problem in the middle. Why? It's discontinuous. If you graph it, you have the function, so you're finding the area from here to here. That goes up to infinity, this goes down to minus infinity. You have a problem somewhere in the middle. You have to figure out how to deal with it, yes? Oh, you don't even know how to graph it. How do you know it's discontinuous? Well, it's equal to 0 at 2 in the denominator, right? So the denominator is 0. So when you see a definite integral, and you see a place where it gets undefined, then you have to break the integral up. Okay? It's annoying, I know. Yes? We only have 7 more weeks of math. For some of you? Yeah. The finals on May 11th. You'll see in a minute. Gotta be patient. You have to see who can get to it on their own first. So you do the limit, you do the two integrals.
Why would you fight it?
Alright, so let's pick a letter. How about, did you T for Trump? No. B for Bernie. Okay, so, limit goes, from B goes to 2 from below, from the left side, 0 to B, dx over x minus 2, plus the limit if B goes to 2 from the other side of B to 3, dx over x minus 2. As I said, you don't need to know how to graph this, although you should certainly be able to graph 1 over x minus 2. If you can't, it's okay, I forgive you, but you should be able to. Alright, so the integral of dx over x minus 2 is just the natural log of the absolute value of x minus 2, evaluated from 0 to b. And I'll do the other one in a second. So you plug in b and you plug in 2, and you're going to get ln of b minus 2 minus you can just call that log 2, because the absolute value is negative 2. Now, when b goes to 2, you're going to be doing the natural log of 0. The natural log of 0 is undefined. Okay? So, this does not exist. So you're done. You could just say this diverges. And since one part of the integral diverges, the whole thing diverges. Okay? So as soon as you get to that step, you're done. Yes? There's no other answer you can write. You can write diverges, you can write divergent. Yes? No, don't put infinity, put divergent. Or diverges. Or diverges. If you grew up in a different part of America. Okay? Don't put infinity. Put diverges. Okay? As I say in the South Shore, we take the edges. Alright, let's do one more. And then we do something new. Try to find a good sample problem for everybody. I mean, these can get really kind of fun, but not really. They're too much entertainment value. How about we'll do let's do that integral.
So if you actually, so that's the answer. That's minus 2. Don't use that long. That's what off x looks like. So log x minus 2 is just shifting to the right. As you get closer to 2, it's going to be negative 10.
Alright, let's do this one. Then we're going to learn some new stuff. So much fun. I do this, I could have been working on Wall Street, making zillions of dollars, treating people badly, making the world a worse place. But no, I had to go and teach math. Was that out loud? Microphone was on? Crap. I hate when that happens. Alright, so how do we do this? So again, we have infinity. So do the limit as h goes to infinity. You guys can decide later what h stands for, it doesn't really matter. I'm doing this, I'm being silly about this for a reason. Some people think it always has to be the same letter, or that the letter has some special meaning. It doesn't. Okay? It's just a letter. Alright. So we just have to integrate e to the minus x. That's e to the minus x. That's minus e to the minus x. So it's a limit h goes to infinity, minus e to the minus x, from 1 to h. Minus e to the minus x is negative 1 over e to the x, from 1 to h. Alright, now we're going to plug in h in 1, and we're going to get limit h goes to infinity, negative 1 over e to the h, plus 1 over e. That's an h, you can't tell. And in infinity, e to the infinity is infinity. Remember what e looks like, right? E looks like that. So, when x goes to infinity, e goes to infinity, right? So this is negative 1 over infinity, which is 0, plus 1 over e. This just goes to 1 over e. So when the integral converges, you will get a number. When the integral diverges, it's because you're going to have an infinity in there somewhere. So just write divergent and move on. Yes? Remember, e to the minus x, e to the minus x is 1 over e to the positive x. Okay? Other questions? So believe it or not, you're now done with techniques of integration. This is the hardest part in some ways, because it's all just sort of playing, manipulation and playing and finding tricks to solve the kind of integrals. Now we're actually going to learn how to use these integrals. Okay? So if you're wondering, we're now shifting from chapter 5 to chapter 6. Bless you. Okay? So, the reason we do technique of integration is you'll set up a problem, and you'll get some kind of integral, and then you have to actually evaluate the integral. So for those of you who do go on into real higher level math and physics and engineering, you'll do a problem, and you'll set something up, and you have to be able to solve it. And these techniques are ways to solve it. And you run into a lot of infinity stuff, especially when you move into higher physics, quantum mechanics, things like that. Any planning to take quantum mechanics? I'm going with no. Maybe somebody here will. And then you'll do lots of this kind of stuff. Okay? You can learn about black holes. Black holes go down to infinity at some point, or up to infinity, depending on your point of view. There's really no down and up out there in space. So you can tell this to your parents, they'll be very impressed. And they'll say to your friends, my kid's so smart, and that's good enough. Alright. So now, we're going to do more on areas. I just like saying it that way. Don't know why. More on areas. This is my exercise. I have a very large left shoulder at some point. So remember, an integral means a bunch of different things. An integral is a giant sum. You can add things up using an integral. An integral is also an antiderivative. It's the opposite of the derivative. You're going the other way. An integral is also area under a curve. So now, we're going to use integrals to find some more interesting areas. Okay? So, remember what I just said a second ago. An integral is a sum. The S stands for a giant sum. Okay? So suppose you have one curve and then a different curve, and you want to find the area between the two curves. Okay, so let's call that f of x, and let's call that g of x. So you imagine that you want to find the area between these. So remember we did the rectangles before, so you can do the rectangles again. You can say, suppose I have a rectangle, like that. Just imagine it's very thin, okay? So what would the height of that rectangle be? Any ideas? Why is that true? That's an excellent answer, but you need a little more. Very good. Alright, so this distance is f of x. This distance is g of x. Pretend they're the same x, okay? Very good. So, you have this distance is f of x, this distance is g of x. So the distance between the two of them is f of x minus g of x. And the width of that rectangle is delta x. So the way you turn that into an integral is now you want to add all of them up. So you would do f of x minus g of x, and then you do the limit as delta x gets closer and closer to 0, that becomes dx. You go from A to B, and that is the area between two curves. For example, okay? So let's say we're going to find the area between y equals x squared and y equals 2x minus x squared. So one of the unfortunate parts is you have to do these graphs. We will probably give you a couple of points for drawing the graph correctly. Okay? Which means if you do the problem incorrectly, but you drew the graph correctly, you'll get something. Okay? The graphs won't be incredibly complicated. There'll be things like quadratics and cubics and sines and cosines and e. It can't be too hard because you have to do a couple of important things with this graph. So, y equals x squared is parabola, and 2x minus x squared, that's the same as x times 2 minus x. So that's an upside down parabola through 0 and 2. So here, I'll blow that up for everybody to see. So this is x squared, that's 2x minus x squared, and we want to find that area, and this is the origin. You know, when you miss, just make a big dot around it, so people can't tell if you do it wrong. Okay, so now you have to find where they intersect, because we're going to go from 0 to that spot. So where do they intersect? They intersect where 2 minus x squared equals x squared. So that's 2x minus 2x squared equals 0. Factor out of 2x times 1 minus x equals 0. So they intersect at x equals 0 and x equals 1. So then the area is simply, you need to go from the left side to the right side, so this is x equals 1. And what are we doing? Well, we're adding up all those little rectangles, so all those slices from 0 to 1. So you can go from 0 to 1, and each slice has a height of the top curve minus the bottom curve. So 2x minus x squared is on top, minus x squared dx. You should all be able to integrate something like that. It's not a tough integral. Move that. All right. We'll leave that there for a second. So the integral of 2x minus x squared becomes 2x minus 2x squared. Okay. The integral of 2x is x squared. The integral of 2x squared is 2x cubed over 3, evaluated from 0 to 1. If you plug in 1, you get 1 minus 2/3. And when you plug in 0, you just get 0. So this equals a third. Okay? We understand this one? So what you're going to do is you're going to integrate the top curve minus the bottom curve, starting at the left side and going to the right side. Of course, we can make these very annoying because we can just ask harder areas. Ready for another one? I heard yes. That person who said no, you meant yes, right? I heard yes again. Oh my gosh. I get my hearing checked. Okay. How about from y equals x to y equals 5x minus x squared? So practice drawing the picture.
Well, sometimes I'll give you pounds. We do 3 or 4 players. I didn't know he was back. Yeah, he likes that. Who's ready? You should come by. Hi, Mommy. Is she ready? Too easy. Very hard to get. So that Michelle. You guys have this one? No? There's so many good choices. Drama.
Goes across. The guys are good. No? It's a really great experience. The best part is the next morning. You face down. It's not for that. That's never happened to me though.
Hi, Bunny. Nia wants to play with you.
We got this. Get it.
No.
Don't worry about the issue. You know, when people watch the videos, they go, where does he go? He puts the problem up and he just walks away. He's talking to himself. So you're going to have to practice doing these graphs. I mean, if you can't graph y equals x, I'm nervous. I'm not sure I want you to do the open heart surgery when the time's up. What does y equals x look like? Y equals x, well, kind of looks like that. And 5 minus x squared kind of looks like that. It's a little exaggerated, but that's the difference. So you want to find the area of that shaded region, and you're going to do is you're going to slice it like that. You're going to add up all of those slices. We use the word slice for a reason. Okay? Because what we're going to do next week is we're going to spin the slices. I know you're looking forward to that. Okay. Now we have to find where they intersect. So they intersect where these two equations are equal to each other. So where x equals 5x minus x squared. Subtract x from both sides. You get 0. 4x minus x squared. You put 6. Not 6, it's 4. Pull out an x. So this is where x equals 0, or x equals 4. So this is x equals 0, x equals 4. So you're slicing from 0 to 4. So we're going to want to evaluate from 0 to 4, top curve minus bottom curve. So top curve is 5x minus x squared. Bottom curve is x dx. Okay? So let's do that integral. That's the integral from 0 to 4 of 4x minus x squared. You will find that that integrand equals this integrand a lot of the time. Okay, so what's the integral of 4x? It's 2x squared. And x cubed over 3 from 0 to 4. Now look, if you're lousy at the arithmetic, plug in the numbers and leave it. Okay? So if you're not so good at the arithmetic, at least write 2 times 4 squared minus 4 cubed over 3 minus 2 times 0 squared, which is 0. 0 cubed. So that whole right side is 0. Okay? If you're not so great at doing 32 minus 64 thirds, that's okay. I'd rather you leave it like this than do the last step of arithmetic and get it wrong and then lose the points. Okay? But you should get 32 thirds. Okay? Or 10 and 2 thirds, or for those of you who use your calculators, 10.666. If you put 10.666, we're going to be suspicious. Okay? Sorry? Once in a while we catch somebody doing something that makes us nervous. No calculators in the exam, no phones, no watches. We're on to you guys. Okay? None of that stuff. Where you watch, we're going to assume you're cheating. Yes? You got them backwards? Yeah, you had it backwards. Because you had it's the top curve minus the bottom curve. You did the bottom curve minus the top curve. Right? You want what's on top minus what's on the bottom. Now, how can this get interesting? How do we make this more interesting? Well, first of all, the top and the bottom could switch. We love trigonometry, right? I know you love trigonometry so much. Okay. So what does y equals sine x look like? Sine x looks like this. Cosine x looks like that. Right? So at pi over 2, I didn't draw it exactly to scale, but hang on. Redraw that so it looks prettier. Okay, so that's the 0 to pi over 2 mark. Sine curve should be at its peak there. I'm going to be a little obsessive about this one more time, because it's going on the video. Not that we edit the videos. Alright, there you go. The sine is at its top when the cosine is at 0. So in other words, this is cosine x, and this is sine x, but right here, they switch, and now this is sine x, and this is cosine x. So what do you think we do? What do you think we have to do? It doesn't matter which one we use. Yeah? Break it into two integrals. Okay? So where does sine x equal cosine x? 45 degrees, or pi over 4. So right there, it switches from 0 to pi over 4, cosine is on top and sine is on the bottom. From pi over 4 to pi over 2, sine is on top and cosine is on the bottom. So you have to do the integral 0 to pi over 4 cosine x minus sine x dx plus the integral from pi over 4 to pi over 2 of sine x minus cosine x dx. So much fun. Okay. The integral of cosine is minus sine, and the integral of sine is cosine. So this is minus sine x. I'll move it over here. So you get minus sine x minus cosine x from 0 to pi over 4 plus minus cosine x. Did I do that correctly? That's sine x, not minus sine. Sorry. Right? And then you're going to have, that's, hang on. So this is plus cosine. Got it. Alright, and then this is minus cosine minus sine pi over 4 to pi over 2. Okay? You'll know you did it wrong when you mess up the minus signs. You'll get the answer and it won't make sense. You'll get a negative answer or it'll be too small or something. So, sine of pi over 4 is radical 2 over 2. Cosine of pi over 4 is also radical 2 over 2. So this becomes radical 2. Right? Radical 2 over 2 plus radical 2 over 2 is just radical 2. You plug in 0, sine of 0 is 0, and cosine of 0 is 1. Okay. Cosine of pi over 2 is 0, and sine of pi over 2 is 1. So, and pi over 4 is going to be minus radical 2 over 2 minus radical 2 over 2, which is minus radical 2. Made a mistake somewhere in there. The whole thing is canceling out, which it shouldn't do. Oh, it's a minus. Sorry. Right? Now I'm confused. Let's see. No, that's minus 1. Minus minus, right, so plus. Good. So you get 2 radical 2. Okay? I'll double check that later. See, I mess up the minus signs also. Alright, another thing that you could do is instead of integrating with respect to x, you might have to integrate with respect to y. You can check me later. Okay, so we want to find the area. Okay, so now you want to do between x equals y squared and x equals 8 minus y squared. So what does that look like? X equals y squared is a sideways parabola, and x equals 8 minus y squared is also a sideways parabola. Well, if you try to isolate it for y, you're going to run into some problems. Okay? Think about your slices. When you're slicing from here to here, it's the same curve on top and on the bottom. So it'd be messy. You have to break it up from here to here, and from there to there. Or instead, you slice sideways. Like this. And you add up all of those slices. It looks hard, but it's not. So it's basically the same thing as before, except you turn sideways. Everything, instead of being in terms of x, is terms of y. And instead of top minus bottom, you do outside minus inside. So this is the curve 8 minus y squared. And this is the curve y squared. So where do they intersect? Well, 8 minus y squared equals y squared, where 8 equals 2y squared, 4 equals y squared, so y is plus or minus 2. Okay? So down here is at y equals negative 2, and up here is at y equals 2. It's the same idea as before. You're going to integrate. You integrate from minus 2 to positive 2. And outside curve is 8 minus y squared. Inside curve is y squared. By the way, you could go from 0 to 2 and double the answer. You notice the bottom half should be the same as the top half. It's symmetric. So one trick you can do to make your life easier is just integrate from 0 to 2 and double. Does that make sense? Okay? Because even though I don't draw it beautifully, the top half of this picture is the same as the bottom half of the picture. So one of the things you can do in integration, especially in these area problems, is if you see that sort of the left and the right side are the same and the top and the bottom are the same, you could do half the integral and then double. Lots of times doing half the integral will mean one part of the integral is evaluated at 0, which is easier. Okay? So this becomes integral from minus 2 to 2, 8 minus 2y squared dy, which is (8y minus 2y cubed over 3) from minus 2 to 2. So you plug in 2 and you get 16 minus 16 thirds minus 16 plus 16 thirds. So these two are not the same. So it becomes 32 thirds plus 32 thirds, or 64 thirds. Okay? And as I said before, feel free to leave it here, or just plug in without doing the cubing. It's fine with me. Okay? We're not that fussy in getting the arithmetic exactly correct. It's more important that you understand what you're doing. So let's give you guys one to practice. find the area between x equals 1 minus y squared and x equals y squared minus 1.
That sine and cosine problem is 2 radical 2 minus 2. So also minus 1 in this. For those of you who really care about that stuff, so go home, catch it later, send me an email, say you're really confused, or that I made a mistake. So it's 2 radical 2 minus 2. Can you agree with that? Now you don't have to ask me after class.
Second last one.
So let's see.
1 minus y squared, you go to 1, and then you go this way. And y squared minus 1, you go to negative 1, and you go this way. And again, they're going to be symmetrical. Where are they going to intersect? Or where does 1 minus y squared equal y squared minus 1? Well, that's where 2 equals 2y squared, y squared equals 1, y equals plus or minus 1. And these actually intersect on the y-axis. So the right side equals the left side. So you could integrate from 0 to 1 and double the answer. Okay? And as I said, that often is easier to do. So let's do that this time. So the right-hand curve, this curve, is 1 minus y squared. That's an arrow. And this curve is y squared minus 1. So we would be integrating from minus 1 to 1, the right-hand curve, 1 minus y squared, minus the left-hand curve, y squared minus 1, dy. And by the way, if you did this and you got a negative number, you probably just did it backwards. You had your right and your left reversed. Now you could make this instead 2 times the integral from 0 to 1 of 1 minus y squared minus 1 dy. Why are you allowed to do that? Because the right and the left are the same. If you just integrate from 0 to 1, you get some answer. You just double it. Okay? So this equals 2 times the integral from 0 to 1 of 2 minus 2y squared dy. So these, as I always say, you just have to be careful. You have to be careful with the minus signs and be careful with the arithmetic. Yes?
What if you take down the 2 and multiply by 4?
Oh, you could do that. From here you could take the 2 out. Absolutely. Sure. I would do that. Okay? But I don't like to confuse too many people. But yes, you could pull a 2 out of here. Okay? So this becomes 2 times 2y minus 2y cubed over 3 from 0 to 1. So you plug in 1 and you get 2 minus 2/3, right? Which is 4/3. You plug in 0, you get 0, so it's 8/3. Be careful, by the way, you don't always get 0 when you plug in 0 in an integral. You don't, for example, when you have cosine of x. If cosine of 0 is not 0, it's 1. So be careful. Don't automatically assume that part is 0. Okay? Everybody had enough? See you on Monday.